Ingenero, we have been doing this now for several years. We've actually got several implementations that deployments we've done of what we call applied AI systems across several different regions in North America, Asia Pacific, Europe, and so on. And several different use cases, and we've got about 50 plus digital solutions actually operating in refineries, midstream, petrochemical, specialty chemical facilities, covering all kinds of use cases, whether it's sustainability, safety, productivity, profitability, and so on. Now, as a company, we have been doing analytics. We had a very prescient model when we first started in 2001, remotely supporting operating plants by taking data and doing analytics using what we call ML today, data-driven as well as fundamental models. And that, since 2015, we've been actually deploying automated systems for our clients. So what is applied AI? Data, yes, we've got all kinds of data lying. We were talking about this earlier. It's in all disparate areas, but there's enough data when you talk of process manufacturing. Over the last decade, there's been tremendous improvements in hardware, computing power at much lower costs. So that has spawned off a whole lot of what I call digital solutions, which is where we've seen the ML, AI type solutions, the IoTs, and there's a whole bunch of what we call digital solutions. Utilizing this, I mean, that's really the whole area we're talking about. It requires a fair amount of specialized engineering, whether we have data engineering, like it was mentioned earlier. That's a key place you start. A lot of people gloss over it, but that's very, very important, and it's fairly time consuming, having the right data, the relevant data, making sure it's processed properly, and then the analytics piece, and then the decision engineering piece. All these are very important engineering aspects, which I call applied AI engineering. And that's really what provides the augmented intelligence to give you all the better results for whether it's sustainability, productivity, and so that's the whole area of applied AI. Applied AI using these ML models or even fundamental models in combination, hybrid models, it's a very important part of any digital solution, because at the end of the day, we've worked with customers where they've taken the data, they've created great visuals, but we've often heard that, hey, we're getting nothing out of it. So that's where you really need to get into the deeper analytics to make more sense of what the data is saying. So what is really an applied AI system? What does it look like? You have it collecting the data, doing the auto analytics, ability to do different kinds of analytics, whether it's descriptive, diagnostic, predictive, prescriptive. Feedback is taken, and the AI models are continuously improving based on the feedback, implementation, and then you have the other ability with that is with the IIoT, what I call actually Internet of People, because your ability for people sitting remotely to actually access all this, run what-ifs, and provide additional inputs and insights. Because here today, with all this, you are able to actually take the data to the experts rather than experts going to the data. And so at the end of the day, that's really implementing of that. Once in an advanced state, it'll be auto-tuning, auto-running, auto-adapting, and closing the loop, like we heard from IOCL, is very important at the end of the day. But you have to build the credibility of these systems before that last step is taken to automate it, either with robots or APC or whatever. And that's really where the value comes in. And so there's a whole staged, phased approach to get there, as we've been discussing in the panel. So the key objectives really for doing an applied AI application is really, what are you trying to get out of it? Do things, be able to do more things, better, faster, automate rote tasks. And at the end of the day, very important aspect which often gets overlooked is the learning. You don't know what you don't know. And systems like this can actually provide you with that knowledge and raise the bar on what you can do beyond. And the applications, where do you use it? Like we mentioned earlier, it could be safety, sustainability, reliability, productivity, yields, and that's the whole thing. So in the sustainability area, one very important aspect, there's actionable sustainability. What I call actionable sustainability, three areas. What best can I do with what I've got, the assets that I've got? And this is where a lot of the operational AI comes in. We're working with operating plants, being able to monitor it better, improve the performance, get better prescriptions, and so on. So automatically that will improve your emission profile, be able to run better, improve your raw material usage, and so on. So that's one direct application which is very important. The other area is, of course, digital solutions, improving upon your even designing of things. So that's the second area where I call short-term projects, whether it's using biofuels, using alternate fuels, or circular recycling. All these bolting on to improve your emissions with carbon capture. All these require new and improved designs, and that could be done a lot faster with, again, with digital solutions. And then, of course, there's the third, more long-term, which is more strategic, which is, I'd say, 2030 and beyond, maybe intensifying processes, electrifying, the cracker, for example, longer-term projects. So let's quickly look at what I was talking earlier. It's really an end-to-end. When you talk of applied AI, you start with data, you have to process the data, do the model, put the models in place, make it accessible across the board, remotely as well as locally, and then integrating it with your workflow, having access for people across the board. So it's really a conglomeration of various different kinds of technologies that ultimately provides a solution. One thing I would like to point out here, and that is, people talk of models. It's not as trivial. Building, even just like you hear of foundational models with generative AI, building foundational models in our domain is also very important. There's a lot of training, a lot of testing that has to happen before you can have a very robust model that you can hang your hat on. At the end of the day, whatever results come out of this, you can very quickly lose credibility if you just very quickly, take a data model, throw it in there. People can tell you that you can do it in a week. That's far from the truth, because really it takes time, and you have to put models out there with enough testing that has gone in to make sure that the usage happens and there's enough credibility that's built. We've done this at several places. I'll just run through several results that have come from several of the case examples that we've deployed since 2015. This is an ethylene complex in Middle East, where they've really been able to expand their run lengths, expand the time between turnarounds, improve production and reliability, and so on. And tremendous improvements. This is something that they've been able to actually project. Here's an example with an acetylene facility. You'll see some of the improvements, direct impact on sustainability coming from here. Better usage of hydrogen, decreasing losses of ethylene, improving ethylene production, and improved fuel, and so on. Another example, steam balances across several US refiners where this was done. Again, this is not just a dashboard that just throws numbers and shows you what is happening, but it also does a lot of predictions and prescriptions, live benchmarking, telling you what what was the best before, what can be done better, and so on, an intelligent dashboard. And this has really provided a lot of benefits to this refiner we've been working with. Another example, these are places we worked with delayed coker, various areas like predicting outage, which is not very easily measured and is always prone to a lot of errors. So areas like that where these were some of the use cases where it was done, predicting fouling, the furnace performance, and tremendous benefits, whether it's from the turnarounds or better planning and so on. And my last slide here, just to give you an idea, this was done, we've done this across several different furnaces where these are dashboards, intelligent dashboards that actually show you clearly what the fouling situation is and prescribe how you can be running the furnaces better. And that has really provided tremendous benefits to the customers where this has been implemented. So that kind of in a nutshell is what I wanted to share with you. We have a booth here. If any detailed questions, feel free to drop by and we'll be more than willing to answer. A lot of my colleagues are here with me.